You're looking at this, I want you to think, what was happening in this first step here? From the first step to the next step, what did we do? We removed x's, we were subtracting x from both sides, right? So if we are asked to justify each step, we're subtracting x from both sides. I need some of you writing with us. Then the next thing they did is after they did that, then you divided by 2, right? So that's what we were working with when we did those algebra tiles, okay? What we want to take a look at is the next, on that next part down. And as you look at the next part down in your notes, we want to only look at a couple questions, and I want you to get started in your homework. And those of you that are not done with C5, I want you to do C5. So we are going to take a look at question number 1. This is like the 12 rectangles, right? Plus the 7 little ones equals, this would be 6 rectangles on this side, right? Plus 11 of those little ones. If we were thinking of those algebra tiles. Someone said, that doesn't help me. Other people said, oh, that helps me to keep track of it. The next thing I want you to do, Elijah, is write this line all the way down and do one in number 5. These are the 2 that we're going to do. When you start solving your problems from now on, for some of you, that line is going to help you because you always have to keep it balanced on both sides of that line. Okay? So, if we are taking a look at this one, I want to get all the rectangles on one side. I have 12 of them, and I have 6 on this side. We're going to subtract 6t on both sides. When we subtract that 6t on both sides, Fauna, we're going to end up with 6t
plus 7 equals 11.
So that gave us a 0. My goal, remember, is always get all the variables equal to the numbers. So Katie, I'm at 6t plus 7 equals 11. What do I want to do next?
Subtract 7 from both sides.
I'm going to subtract 7. So when I subtract 7 on both sides, Haley, I'm going to end up with 4 equals what on the other side? 6t. So my next step, Aline, is going to be to do what? Divide 6 by both sides. Now, you could leave your answer as 4 6. I take that. We could write it as simplified 2/3. We're not going to write it as a decimal. So now we want to just make sure if we were going to check it that we did it right. So right now we think t equals 2/3, right? Go up here and take your calculator out. So if you have your calculator, if you don't, grab one at this time. 12 times. We're going to write it this way because this is how you probably put it in your calculator, right? 12 times 2 divided by 3. And I just want you to notice you wouldn't even have that parenthesis, right? Probably you'd put times 2 divided by 3, and then you'd put plus 7. And if you put in 12 times 2 divided by 3 plus 7, we end up with 15. So we know 15 is what we got on this side of the equal sign. So Juliana, how do I check the other side? What am I going to do? I'm going to put 6 times what?
2/3 plus 11.
Yeah, put that in your calculator, please. 6 times 2 divided by 3 plus 11. Did we get 15 also? Yes. So that's how you do the check a little differently when you have variables both sides, right? Still not hard, right? So now we got to continue. You ready, Emily? We're going to do question 5. Question 5. We have to distribute first. What am I going to get when I start distributing? 3n minus 3. This is still going to be equal to the side of 2n plus 15. Okay? Right, what do you do next? Right, because we want all our rectangles on one side. So what are you going to do when you take the 2n? Subtract it. So we want to subtract 2n from both sides. Okay? Keeping in mind that this is like that rectangle. So we have that one rectangle by itself, 1n. Some of you don't like writing 1n, you want to just write n, no problem. Minus 3 equals 15. What next as I'm looking at it, Mia? I'm going to add 3. And if I add 3, I end up with n equals 18, right? So if n is equal to 18, what does my check look like? My check is going to look like 3 times, what is 18 minus 1? Could I just write 17, 3 times 17? Isn't that 18 minus 1? So I could write in my check 3 times 17. Does that make sense? 3 times 17 is how much? 50 what?
51.
51. Now on this side, I am going to put the 18, right? I'm going to put 2 times 18 plus 15. Did it work out? Get 51 on both sides, so I know I was doing it right, and this is the right answer. Now, if we would have made a mistake someplace, like someone would have put a 1 here, hopefully you would have found that mistake, right? Because then you would have had 14 for an answer, and 14 would not make this true. Only 18 makes it true. It's the only solution for this. Later, this unit, we're going to have answers where it's going to be infinitely many solutions and no solution. But right now, we only have this one answer for our solution, okay? So, we're going to look at this situation on the top of the next page. So, Zach, would you do me a favor and read about the trees for us, the planting?
2 trees are planted in a yard. Tree 1 is 14 inches taller than tree 2. Tree 1 grows at a rate of 6 inches per year. Tree 2 grows at a rate of 8 inches per year. In how many years will the 2 trees be the same?
All right, so they say sometimes it's easier to write a model first with words than translate it into an equation. So we started with our tree, which had an additional height. And then how fast is that tree growing times the number of years? Now notice the question said how many years, right? So this is our variable, maybe y, right? Because that's what we're trying to find. So the additional height was what, Ashley? How much taller was tree 1 in that first sentence? 14. Plus, how fast is it growing, Andy? Tree 1. Tree 1 is growing at a rate of what? 6 inches per year. So we're going to have this growth rate of 14 equals 6. And then it's times the years, but we don't know how many years, so we're going to just put 6y, right? Equals, right? So we're up to our equal sign. Growth rate of tree 2. What do we know, Elizabeth?
We know that tree 2 grows at a rate of 8 inches per year.
So we are going to write 8y. So Elena, if I'm going to solve this one, what are you going to do? Think of our rectangles. We have 6 is a rectangle, the 8 rectangles plus 14 little ones. I need all the rectangles on the same side. What would you do? Subtract 6y. Getting our number by itself. Nice work. And what would you end up with?
2y.
14 is equal to 2y. And we are going to divide by 2. And our answer for this one is 7. So we put down in how many years? 7 years. Done. Now, the next question, if you look at the bottom of that next page in your notes, way at the bottom, Juliana, what does it say way at the bottom of that bottom screen of your notes? You see that way down here?
There's a question mark just within some minutes.
So, it might be a really good idea when you're doing your notes and you're doing your homework and you're getting ready for that quiz, if you go back and you look at this question, because you're going to see one like it on your quiz. So you can just, okay? And I always have people say, well, I've never studied for a math test. Well, just go back and cover up the examples we did in class. And sometimes if you haven't noticed on some of our tests, some of the examples are the same as some of the test questions, right? So we do some of that stuff so you've seen it before. All right, so in this one, what does it tell us first? Each side of the triangle is the same length. How long is each side? So here is our word model. If we know these, all 3 sides are the same, could we start off with just saying the left side is equal to the right side? Doesn't that make sense for our figure? On one side of the triangle, or you could put 2 sides are equal. I would take that also. So we're going to write that right in that blank. Left side equals right side. And if I was writing, Aiden, what is the left side looking like?
Left side, 2 Wait, 3x plus 5?
3x plus 5. And then I'm going to put is equal to the right side of the triangle, which was?
5x minus 1.
Yeah. So now, Elijah, I'm thinking if I got to get all those x's on the right side, right? I want to move them. Which one do you want to subtract from both sides?
5x.
5x. Would some of you maybe have subtracted 3x?
No.
Does it matter? No. I've done it today subtracting 3x, but we're going to subtract 5x. We're going with Elijah's telling us what to do up here. So what do we end up with then when you do that, Elijah?
-2x.
Nice job. Negative 2x plus 5 equals, on this side, what do I have? Katie. Negative 1. So, Aiden, this is where a lot of people, like in your homework today where you're asking, just put down 1. You got to keep the sign with that, okay? So, now, what are we going to do, Angel, to get the negative 2x by itself?
Minus 5 on both sides.
3 minus 5 on both sides. We get negative 2x equals negative 6. By the way, when we've solved this earlier, I have had people do it this way, where they did 5 equals and they had 2x plus minus 1, and then they said, so I just want to show you, it doesn't matter which way you do it. Both ways, here you have 6 equals 2x, here you have negative 2 equals negative 6. What's going to happen when we divide both of these by negative 2? We get x equals 3, right? What would happen here if you would have solved this one, doing it the other way? If someone said, you know, I would have subtracted 3x as my first step, do you get the same answer either way? If you do it correctly, you should always get the same answer both ways. So I just want you to know there's not one, if someone said, well, I did this first, and you said, well, I did this first, it's not wrong, it's just there's multiple ways of doing that. So the question is, how long is each side? No, it's not 3. X is 3. What's the length of the side? Where are the sides at? Aiden, when you told us at the beginning.
3x plus 5.
Oh, 3x plus 5, and these are the side lengths, right? So what do you have to do with that x of 3?
3.
We got to plug it in, right? Does it matter which side you plug it in on? Not at all. 3 times 3 plus 5? 14. 5 times 3 minus 1? 14. They had to come out the same, right? That's kind of like our whole checks we've been doing. That's what the check is asking you kind of in this one, okay? So it should have been, as we were looking at that, 14 inches, right? As you were looking. So keeping in mind that you will probably see one like this again, right? In one of our tests. So your homework tonight is looking at this page. And right now, let's look at number 7. And I want you to look at number 7 and read through it, and I want you to try to write